Okay, so in this lesson, we're going to learn about solving systems of equations. But before we do, it's important to understand what a system of equations looks like and what we're talking about when we're talking about a solution. So here's our system of equations. You can see it consists of two linear equations, each having an x and a y, though not every time you see a system is it going to have an x and y. And often the system will have a braces, depending on the textbook really, around the system, indicating that these are two equations that we're looking at the same time. So the question then is, what is a solution? Meaning, what does a solution to this system look like? And the answer is going to be an x and a y that works when you plug it into both equations. So the xy has to work in both equations. Now we know that for any linear equation, there is an infinite number of x's and y's that will satisfy that equation, and it graphs a line. Right, so we know, for example, that if we have a certain equation and we have the line of that equation, every single one of these points on this line here are going to work if you plug them in as x and y into the equation that you have. So the question is what happens if we're talking about two equations at the same time? So here's the deal. There are three options for what a solution to a system of equations look like, and the best way to understand it is to go ahead and look at the graphs. So here's our first option. We have two lines, they intersect at a very specific point, that's this point right here, and that system has one solution. That is the only x and y that actually satisfies both equations. We can see that it lies on the equation of this line and it lies on the equation of this line as well. Our second option is that the two lines are parallel, and don't forget when you're going through this that parallel lines have the same slope. So these two lines would have the same slope. They are parallel, and as you can see, every line here, every point on this line satisfies this equation, and every point on this line satisfies this equation, but there is no point that lies on both lines at the same time, which means that there is no solution to this system because there's going to be no x or y, or x comma y, that will fit on both lines at the same time. This sort of system of equations is often called an inconsistent system of equations because it has no solution. And last, we have our third example, where you can see that these two lines are actually graphed one on top of the other, which means that every point on the first line also works on the second line. And so this system has infinite solutions because every single point from the first equation will work in the second equation as well. And this sort of system is often called a consistent system, or it's known as an identity, because again, the two lines that you're looking at lie one on top of the other. So these are our three different options for systems of equations. So the last thing we need to figure out is how do we go about solving this system of equations? Well, we have three possible ways to solve this system. The first one is by actually graphing the lines. You take your graph paper, you graph the two lines, you see are they parallel, do they intersect, where do they intersect, etc. And that's probably the most straightforward way to do it. However, if you don't have graph paper or your lines intersect at a point that's not a two perfect whole numbers like 2 comma -3 and it ends up being something like 1/2 comma 4, that's kind of difficult to see what the answer to the system actually is. The other two possibilities are a method called substitution and then a method called elimination or addition, depending on what your textbook chooses to call it. And in the next few videos, we're going to learn how to use substitution and elimination to solve systems of equations as well.